Welcome to Unit 4 of M3. Unit 4 looks at motion in a circle. So, here I've got a circle, radius r, and I'll just go through a couple of basic points. Omega is defined as the angular frequency. Now, if you express the angle of a circle in radians, it's 2 pi. So it's 2 pi, the number of the angle, multiplied by the frequency, hence angular frequency. It can be calculated using the time taken for a complete revolution, or it can be calculated from the frequency. The velocity of the particle moving in a circle can be described as r omega, so that just means that omega is 2 pi over t, the velocity is 2 pi r over t. So that's very logical, because 2 pi r would be the circumference all the way around, and then t, the period, the time taken for it to go around. So it's the distance it goes divided by the time, which gives you the speed. So nice and logical. So we'll start with a simple example. So this little question just asks for you to express angular speeds in different quantities. Okay, so angular speed of 5 revolutions per minute in radians per second. So we've got 5 per minute. So 5 divided by 60 seconds gives us that the frequency is 1 over 12. So if we multiply that by 2 pi, then we get the angular frequency as pi over 6 radians. So that's going to be just less than half a radian per second. B, an angular speed of 120 revolutions per minute. 120 divided by 60 for seconds in a minute gives us 2 radians per second, 2 revolutions per second, so a frequency of 2, multiplied by 2 pi gives us 4 pi radians per second. An angular speed then of 4 radians per second in revolutions per minute. So 4 radians per second divided by 2 pi multiplied by 60. So yeah, there's 4 over 2 pi multiplied by, that'll give you the number of radians per second, or number of revolutions per second. Multiply that by 60 and give you the number of revolutions in a minute. So that's just 120 over pi, which is going to be just less than 40. Final question, angular speed of 3 radians per second in revolutions per hour. The 3 radians per second corresponds to 3 over 2 pi for the frequency, multiplied by the number of seconds in an hour, which is 3,600, and then you get roughly 5,400 over pi revolutions per hour. Okay, and that's about it in terms of simple examples. The rest of it's pretty easy, and then onwards to the next slightly more complicated topic.